Hello everyone, and welcome back to another daily LeetCode challenge. Today's problem is LeetCode 2147, number of ways to divide a long corridor. Imagine a long corridor inside a library. This corridor is represented by a string made up of two characters, S for seats and P for decorative plants. You are given this corridor as a zero-index string. There is already one divider placed before the start of the corridor, and another divider placed after the end. In addition to those, you are allowed to place extra dividers between any two adjacent positions, but at most one divider per position. The goal is to divide the corridor into multiple non-overlapping sections. And here's the key requirement. Each section must contain exactly 2 seats, and it can contain any number of plants, including 0. There may be multiple valid ways to place these dividers. 2 divisions are considered different if at least one divider position differs between them. Your task is to calculate the total number of valid ways to divide the corridor. Because the number of ways can be very large, the result must be returned modulo 10 to the power 9 plus 7. And if it's impossible to divide the corridor following these rules, you should return 0. This problem combines careful counting with pattern recognition. Let's go through the examples next, and then break down an efficient solution step by step. Let's look at a quick example. The input corridor is SSPPSPS. The output is 3, meaning there are 3 different valid ways to divide the corridor. In every valid division, each section contains exactly 2 seats, with any number of plants in between. The black bars represent the 2 dividers that are already installed at the beginning and the end. By placing additional dividers at different valid positions, we get exactly 3 distinct ways to divide the corridor. That's why the final answer is 3. Example 2. Now let's look at the second example. The input corridor is PPSPS. The output is 1. In this case, there is only one valid way to divide the corridor. If we try to add any additional divider, at least one section would end up with fewer or more than 2 seats. So the only valid option is to not install any extra dividers at all. That's why the answer is 1. Example 3. Now let's look at the third example. The input corridor is S. The output is 0. Since there is only one seat in the entire corridor, it's impossible to form any section with exactly 2 seats. So there are no valid ways to divide the corridor. That's why the final answer is 0. Now let's understand the logic behind the solution and see how this problem is solved efficiently. The most important observation is this. Each section must contain exactly 2 seats, so instead of thinking about dividers first, we focus on the positions of the seats. If the total number of seats is odd, or 0, it's immediately impossible to form valid sections. First step is modulo setup. We store the modulo value because the number of valid ways can be very large, and then collect seat positions here. We iterate through the corridor string. Every time we see a seat, we store its index in the list pause. This gives us the exact positions of all seats in the corridor. Invalid case check. If the number of seats is odd, we cannot pair them into sections of 2. And if there are no seats at all, no valid section can be formed. In both cases, we immediately return 0, and then, counting valid ways, we initialize the result as 1 because we will multiply choices for each valid gap. And the core and main logic is counting divider choices using the second for loop. We process seats in pairs. Every pair of seats forms one section between 2 consecutive sections. There may be multiple plant positions where we can place a divider. The number of valid divider positions is the distance between the last seat of the previous section and the first seat of the next section. That distance gives us the number of choices for placing a divider. We multiply these choices together to get the total number of valid ways, after processing all seat pairs. We return the final result. This solution runs in linear time and uses a simple counting strategy. All right, now let's go ahead and run the code. Perfect. All the test cases passed successfully. The logic works exactly as expected. Now for the final step, let's hit submit. And there it is, accepted. All test cases passed. That wraps up today's daily LeetCode problem. If this explanation helped you understand the solution, don't forget to like the video, subscribe to the channel, and share it with fellow developers. I'll see you in the next challenge. Happy coding!